Ever wondered why your AI assistant sometimes stumbles over tricky questions? Or why some tools ace coding but flounder with history facts? Today, we're diving into a breakthrough in AI research, combining models to create smarter systems. Let's break down how this approach is reshaping the future of artificial intelligence. Here's the problem. Most AI relies on a single supermodel to handle everything. But just like a Swiss Army knife isn't perfect for every task, a one-size-fits-all AI has limits. It might write poetry like a pro, but crash when solving math problems. And when forced to tackle complex tasks, it's slow, expensive, and, well, not great. But what if we could mix the strengths of multiple models? That's exactly what researchers at the University of Illinois and NVIDIA did. They didn't just build a new AI, they created a system to strategically blend models, like a master chef combining ingredients for the perfect dish. Let's dive into their tools. First, they built FusionBench, a massive dataset with 100 million tokens from 20 open-source models. Think of it as a library of AI thought processes, from tiny models like QN2, 7B parameters, to giants like DeepSeek R1, 671B parameters. But here's the twist. They didn't just collect answers. They captured how models think. For each question, they asked models to respond in two ways. 1. Directly a quick answer, and 2. With reasoning, a step-by-step explanation. This created thought templates, like a recipe book of problem-solving strategies. Now the real magic happens with FusionFactory, their framework for combining models. It works on 3 levels. 1. Query-level fusion, the traffic cop. Imagine a system that analyzes each question and routes it to the best model. Need code. A coding-savvy model takes over. Fact check. A trivia expert steps in. It's like having a team captain assign roles based on strengths. 2. Thought-level fusion, the brain trust. Here, the system learns from past answers. If a model struggles with math, FusionFactory pulls in a template from a top performer, like getting a cheat sheet from the class genius. 3. Model-level fusion, the team-up. This is where models teach each other. Using a technique called distillation, weaker models absorb the knowledge of stronger ones. It's like a junior developer learning from a senior, without copying code. And the results? When tested across 14 benchmarks, FusionFactory outperformed the best individual models every time. But here's the kicker. The optimal setup varied by task. Math and facts saw moderate gains because accuracy is tricky to fake, while coding and reasoning tasks soared. So what does this mean for real-world applications? Let's take medicine. Researchers are training models like BioGPT and clinical knowledge, encoding on vast datasets of medical texts, research papers, and clinical notes. But how do they handle the complexity of human health? Traditional AI uses supervised learning. It's shown examples with correct answers. But in medicine, data is messy, incomplete, or privacy protected. That's where unsupervised learning shines. Think of it as a medical student reading a million textbooks and journals on their own, picking up patterns and connections without a teacher. This lets models like BioGPT absorb knowledge from rare diseases to the latest drug trials. But medicine isn't just facts. It's context, nuance, and decisions with incomplete info. That's where clinical reasoning steps in. Researchers teach AI to mimic how doctors think, weighing symptoms, considering patient history, and even accounting for cultural or social factors. It's like training a robot to not just recite textbooks, but to diagnose a patient with the same care a human doctor would. And it's not just about knowledge, it's about precision. Techniques like distillation make these models faster and more efficient. Imagine a giant, super smart AI model that's too slow for real-world use. Distillation lets researchers teach a smaller, quicker model the same skills, like a master chef passing their secrets to an apprentice. This means AI tools can run on hospital computers or even smartphones, making healthcare more accessible. But how do we know if these models are actually good? That's where benchmarks come in. Researchers create specialized tests, like simulating patient cases or analyzing medical images, to see how well AI performs. It's like giving an AI a fitness tracker for its brain, measuring how well it handles complex, real-world scenarios. And the results are promising. Some models now outperform human experts in tasks like detecting cancer from X-rays or identifying genetic disorders. Now, let's talk about the broader picture. AI isn't just a fact machine, it's a problem-solving partner. Tasks like natural questions, digging through messy text to find answers, trivia QA, connecting web clues, and AC, holding dynamic conversations, push models to their limits. For math and code, GSM 8K and MBPP test step-by-step reasoning, while math throws in high-level problems that even humans might struggle with. But what makes these models tick? Take QN2 and Gemma. They're like Swiss Army knives, handling everything from language to coding. Code Gemma specializes in code, while Llama 3 shines in conversations. For the big leagues, models like Mixtral and DeepSeek R1 pack billions of parameters, acting like supercomputers that can tackle the most complex reasoning. Here's the kicker, these benchmarks aren't just tests. They're blueprints for progress, showing where AI excels and where it needs to grow. As these models improve, their impact on medicine, tech, and daily life keeps expanding. Thanks for watching. If you're curious about how AI teams up to solve problems, hit that subscribe button. And drop a comment below. What task would you want an AI team to tackle? Let's keep the conversation going.